Welcome to Introduction to Building Codes. Today's presentation is the Bangladesh National Building Code 2020, Part 8 Building Services, Chapter 8 Fuel Gas Supply. The description of this seminar is designed to familiarize and assist code officials, not only code officials, but inspectors, designers, engineers, in describing and applying the applicable code requirements of the BNBC 2020, Part 8, Building Services, Chapter 8, Fuel Gas Supply Requirements, along with selected related codes and standards that are indicated in Section 8.6. The overview of the course is as follows. We will discuss scope, terminology, and general precautions. We will then discuss related codes and standards and their applications, as well as gas piping installations from design to installation to testing. We will talk about and provide examples of installation of specific appliances, gas piping connectors, and materials for these appliances. Our seminar goal is training to allow you to learn and apply key sections and code requirements contained in Chapter 8, Fuel Gas Supply, with selected related codes and standards indicated in Section 8.6 to enhance your performance while inspecting fuel gas systems and appliances. It's very important that we discuss certain key sections here to allow you the opportunity to understand the intent of certain codes and how they apply to parts of the fuel gas system, as well as referencing other codes and standards and appliances for the safety of all people within the building, people working on the gas piping system, and first and foremost, reference to proper design. Next, this training will also provide participants with specific examples related to design, installation, and inspection of fuel gas systems to further enhance your knowledge of fuel gas related construction. The objectives of this course. Upon completion, you as a participant will be better able to do the following. Locate general topics in Chapter 8, Fuel Gas Supply. When we locate topics, it's usually based upon an application. If you have an application to design, install, or even inspect a fuel gas system, you need to locate the proper areas of the code that are relevant based upon your application. We'll go over certain examples. I'll show you graphics and pictures to aid in reading the code and understanding the proper application and parts of the code that would apply. Next, upon completion, you should be better able to locate applicable tables and related codes and standards for specific situations, apply code requirements to real-world situations, explain the intent behind a given code requirement, and last, use good judgment to identify certain fuel gas systems and related components as compliant or non-compliant. Now, if you're new to this industry, you need to learn as much as you can, try to understand the terminology, and over time, you will find when you work with these type of systems, You will be able to use good judgment based on experience, whether you're designing fuel gas systems, constructing them, inspecting them, or even just doing a well-rounded analysis based on fuel gas systems. We will be discussing the scope, terminology, and general precautions related to fuel gas supply, piping, and appliances. Chapter 8, Section 8.1, General. This section regulates aspects of fuel gas distribution systems, including the design, installation, testing, repair, and maintenance. The applicability of this chapter is limited to the customer's side or the consumer side of the gas supply company's distribution system. It does not cover any utility, any company's distribution. We are concerned with this point that the customer receives the supply from the company's endpoint of this system. The code governs all piping and system components from the endpoint of the gas supply company's service line to the supplied appliances and equipment. This is important language because we need to know where we need to start when we reference this code, so it lays out a very clear determination of where we begin our administration, enforcement for design and installation, testing, repair, and maintenance of these systems. The point of delivery is used to determine where the code begins and ends. So that terminology, point of delivery, will be a discussion point for us to go over and clearly see where this code begins and, of course, this code ends. So let's take a closer look at specific sections related to scope, terminology, general precautions, and notification of completion requirements for the fuel gas systems. We will build the system systematically as we go through this presentation. Chapter 8, Section 8.1.1, Scope. This is where we begin with providing requirements that safeguard people and property. As stated in this particular section, 8.1.1.1, this chapter provides the requirements that are aimed at safeguarding life, property, in non-industrial gas piping systems. As stated here, key point, non-industrial. For use with gas, fuel gas, such as natural gas and liquefied petroleum gas, we call it LPG, in the vapor state, used for fuel or lighting purposes in consumers' premises. There's some key points that have come out in this particular section. As I mentioned before, non-industrial gas piping systems. This code covers other types of systems, and as you can see, the fuel types such as natural gas and LPG are in the vapor state. They are not in the liquid state. We cover appliances in this code, such as lighting appliances, heating appliances, things of that nature. Typically, for a natural gas system, the gas supply company's service line terminates at the service pressure regulator and meter setting. So what we're actually stating here is, in other words, the code does not apply to piping and components ahead of the service pressure regulator and meter setting. LP gas storage systems, however, generally remain under the ownership of the gas supplier. These systems are governed by the code through the reference to NFPA 58. This is a reference standard for those parts of the LP gas storage system. Section 8.1.1.2 gives us references. As stated here, this chapter does not cover the safety requirements and rules for gas burning appliances. The requirements come from the National Fuel Gas Code 2009 edition and the NFPA 58 2008 edition, as well as the International Fuel Gas Code 2009 edition of the USA, are needed and shall apply for such appliances. This section gives us the indication and the directive for the code user to reference other codes for the safe installation of gas burning appliances. So we will reference certain parts of the 2009 edition of the International Fuel Gas Code in this seminar, with key areas related to piping systems, appliances, and equipment regarding safe operation of appliances. Section 8.1.1.3 gives us requirements of this chapter that state that it does not apply to gas piping systems for industrial installation and applications. So we must completely understand here that Chapter 8, Fuel Gas Supply, provides designers, contractors, and owners with information regarding whether this code applies to a given application or not. In this case, it's very clear here that any industrial installations and applications are not part of this code. So the chapter does not apply to, of course, the industrial installation and any industrial applications. Further, as we get into the code a little bit deeper, we find that in section 8.1.1.4, the chapter covers the aspects of design, fabrication, installation, test, operation, inspection, and maintenance of gas piping systems, from the point of delivery to the connections with each utilization device. This is important here. Again, we are looking for the start point, and it is stated in this code section. It's called the point of delivery, and it goes from that point to the connections with each utilization device. So where we start on the gas piping system, the customer or consumer side, we take that piping completely, the fittings, the pipe, the valves, everything, into the point where we reach the appliance. The point of delivery is defined in this chapter as the outlet of the service regulator or the service shutoff valve where there is no meter. You can clearly see this here, the boundaries of the gas piping system of which this chapter applies requirements. The code user needs to understand point of delivery is defined in this chapter as the outlet of the service regulator or the service shutoff valve where there is no meter. So it gives us a complete description, whether a meter is present or not, where the demarcation point is that this code begins to apply requirements. For example, the picture that we're showing here is an indication of point of delivery. So the point of delivery is defined in this chapter as the outlet of the service regulator. Also notice the service shutoff valve ahead of the service regulator. What's clearly marked here is you can see towards the middle of the picture, the gas piping system comes up from an underground supply and it rises up into a T. The left portion of the piping system from the branch of the T goes up and services the service regulator and enters the meter and supplies gas to the consumer side. So what we're really looking at here is the point that this code regulates the gas system. And you can clearly see that it is at the outlet of the regulator as indicated. This section in particular gives us further detail. And as you can see, when we step through these sections in the scope, we have more and more details about the system. So section 8.1.1.5 gives us this requirement. Piping systems covered here are limited to a maximum operating pressure of 3.45 kPa. The conversion is 14 inches water column or half-inch PSIG. The maximum pressure must not be allowed to exceed 3.45 kilopascals. Displayed below is a meter assembly equipped with a service pressure regulator that can be set to a safe operating pressure after the point of delivery to the customer's gas piping system. As seen clearly here, the gas supply emerges from the underground piping system. It goes into a valve, which is your service valve, and out of the service valve into the service regulator. As an example, we have a LPG system here. The piping system that are covered here, again, we reference code section 8.1.1.5, and we are limited to a maximum operating pressure. With respect to this LPG system, as you can see, we have a storage tank which contains the LPG gas, perhaps. And on the top of the tank, we have a tank shutoff valve. We have what's called a first stage regulator that reduces the gas pressure from the tank supply. We have piping running from the first stage regulator, dropping down underground, emerging again from underground into what we call the building shutoff valve. From that point, it supplies what we call the second stage regulator. The second stage regulator is where we can reduce the pressure to what is governed by this code, which is 3.45 kPa, not to exceed that final pressure. So, as we look at this again, the LP gas piping system begins at the outlet side of the first stage pressure regulator, as indicated on the graphic. And the piping between the first and second stage final regulator is governed by NFPA 58. The piping downstream of the second stage regulator is governed by this code. In other words, it's the outlet of the second stage regulator as it emerges from that point and enters the building. This is where we begin with the requirements set forth in this code. Section 8.1.1.6. The manufacturer's installation instructions are valued by the listing agency, verifying compliance with the applicable standard. When we look at the listing agency can require that the manufacturer alter, delete, or add information to the instructions as necessary to achieve compliance with applicable standards and code requirements. We look to Section 8.1.1.6 as indicated here as a requirement of our gas code. While applying the provisions of this chapter, reference should also be made to the manufacturer's instructions. Not only the gas company supplies regulations, as well as other applicable codes and standards listed in this chapter or required by the authority having jurisdiction. This is a complete list of what has to be followed when we install, when we design appliances for our buildings that are supplied by fuel gas, whether it's LP gas or natural gas. Now, the manufacturer's installation instructions are a key point here because the appliances have been tested to operate properly. They have been listed by a listing agency to function properly. So the manufacturer's installations instructions are an enforceable extension of the code and must be available to the code official when an inspection takes place. They are key to having requirements on site as to how the appliance needs to be installed, set up, and even started up. Section 8.1.2, terminology, is a part of the code that gives us some good language here because we need to understand the terminology when it comes to gas systems. Not only gas piping systems, but references to components on the gas piping system. We use this section in our code that gives us the language to understand where this terminology comes from. So it starts off like this in Section 8.1.2 terminology. This section provides definition of terms used in this chapter of the code. Where terms are not defined in this chapter, they shall be defined using their ordinarily accepted meanings, such as the context implies. The definitions in the chapter are the same as used in the National Fuel Gas Code 2009 edition. That's the NFPA 54 document, and the NFPA ANSI standard as well for liquefied petroleum gas code, NFPA 58, as well as the International Fuel Gas Code 2009 edition. And the last reference here in this code section is the National Building Code of India 2005 edition. The words or terms defined in this section are deemed to be of prime importance in either specifying the subject matter of the code provisions or in giving meaning to certain terms used throughout the code for administration or enforcement. This section, of course, helps us determine where we can find these key terms that are related to the gas piping system. We need to know what these terms mean to properly understand how the code is communicating to us when referenced. As we continue our discussion of terminology, you must understand that a code provision could be misinterpreted if the definition of a term, as used in the context of the code, is not understood or not completely understood. The following slides will provide key definitions that will assist the code user to properly understand certain fuel gas components, appliances, and various equipment. We need to fully understand the terminology as given to us in this code for proper administration and the intent of this particular code. Codes, by their very nature, are technical documents. As such, literally every word, term, and punctuation mark can add or change the meaning of the intended result. So this really drives us to understand the technical terminology of this code. This chapter contains several terms that are important to understand the provisions of this code. Definitions are found both in this chapter and throughout the code. Let's look at a few definitions. The definition of appliance is defined as follows: any device that utilizes gas as a fuel or raw material to produce light, heat, power, refrigeration, or air conditioning. So we are utilizing gas here as a fuel source. As indicated in the picture, we can see that we have a gas appliance, a gas furnace. The fuel supply to this gas furnace is either natural gas or LPG. And this fits the term appliance because we will use this gas to convert into heat energy through this appliance that is a device that utilizes this fuel for that function. The next definition is appliance valve. This is a device that will shut off the gas supply to the burners. So the appliance valve that we're talking about here is the valve that we utilize, of course, to shut the gas supply off to the burners. Consumers or customers connection. This is the next definition or terminology that we need to understand. You recall the point of delivery. The point of delivery is in conjunction with this definition. And this definition states piping tapped on the riser to supply gas to individual customer or consumer. The indication is showing in the graphic that the customer's connection, of course, is at the outlet of the service regulator. And this is where we have the demarcation for the beginning of the system that is regulated by this code. Very important definition here. In section 8.1.3, General Precautions, we have further information to go over to completely understand what we need to do with respect to any precautionary measures when we work on or install the gas piping system. Section 8.1.3.1 is titled Turn Gas Off. All gas piping work or gas appliance installation shall be performed with the gas turned off to eliminate hazards from leakage of gas. This is very important here because not only do we have to protect the workers working on the gas line, but also the building occupants. We do not want to remove any fittings, any valves, any other components on the gas line without properly turning the gas off. In other words, when you turn the gas off, the function of purging, bleeding the gas out of the lines completely before working on certain sections of the gas piping system is important. And when we relieve the pressure, we want to make sure that we relieve it somewhere to the outside of the building, never inside of the building, because that could create a mixture of gas leaking into the building, mixing with air, and it could be potentially damaging. We need to protect the property as well from potential fire and maybe explosive conditions. So that's why this section is in our code, because it is safety, and it is required for anybody working on the gas system to turn the gas completely off. Section 8.1.3.2, notification of interrupted service. In this particular section, it's the responsibility of the installing agency if the gas supply is to be turned off, to notify all affected customers. This is a notification statement here, of course, to notify the end users. Section 8.1.3.3 is titled Before Turning Gas Off. So before we turn the gas off, we need to verify some things. Before turning off the gas to premises for the purposes of either installing, repairing, testing, or inspection, or even replacement or maintenance of the gas piping system or appliances, all burners shall be turned off. When two or more consumers are served from the same supply system, we need to pay attention, because precaution shall be taken to ensure that only supply to the concerned customer is turned off. So if we look at this completely, we must understand that if you are working on the gas system where you have two or more consumers are served, then we need to make sure that only the customer requiring the service, if the gas must be turned off, is only turned off to that particular customer, not affecting any of the other customers tied to that particular gas piping system. Given the precautions that we've went over, there are a few more safety concerns that are indicated in this code here, specifically smoking. Section 8.1.3.8 gives us this language, this requirement. When working on piping which contains or has contained gas, smoking shall be prohibited. This is a major concern here. We do not need any source of ignition when we're working on gas systems due to the potential of ignition, fires, explosions, things of that nature. The potential regarding the ignition of gas vapors by workers is of particular concern while working on the gas piping. And as seen here, smoking is specifically prohibited in this section. Handling of flammable liquids is given to us in section 8.1.3.9. Flammable liquids used by the installer shall be handled with proper precautions and shall not be left within the premises from the end of one working day to the beginning of the next. Any type of flammable liquids must be taken off the premises. We cannot leave any type of flammable liquids there due to the inherent hazards that may be predicted, that may be affected to the people within the building. They must be taken off the premises at the end of the working day. Work interruptions in work occur whenever they do, the system shall be left in a safe and satisfactory condition. The very last section here on this particular graph or the slide indicates that whenever you have interruptions in the work, we need to leave the system in a very safe and satisfactory condition. If we're working on the piping systems, ladies and gentlemen, and we have to replace a faulty valve, we first begin with shutting down the gas piping system. Opening up the system, replacing perhaps a faulty valve, we need to make sure that the gas piping system has then been tested for any leaks and left in a safe and satisfactory condition. So a good general precaution. In section 8.1.3.11, we are given a direction regarding requirements when we are working on the gas supply system. As seen here in this particular section, certain requirements related to work on the gas supply system are listed in Appendix V. A particular note when you reference Appendix V is that it only applies to work on gas supply systems ahead of the outlet of the meter set assembly or of the service regulator where there is no meter. We have a picture here indicating the meter set as well as the service regulator. So it's very clear that Appendix V applies to systems ahead of the outlet of the meter set. As indicated there in the picture, the outlet of the meter set assembly appears on the right-hand side. If there were no meter, then it would be at the outlet of the service regulator. Appendix V is very clear about where the work begins with respect to the requirements of this code. Appendix V gives us several requirements for working on gas supply systems. In item A, serving gas suppliers main, we need to understand who is authorized to work on the gas supplier's main supply. And it's stated here that no person, unless in the employ of or authorized by the gas supply company, shall open or make connections with the gas main. It is strictly under the regulation of the serving gas supplier. Item B, no person, unless in the employ or authorized by the gas supply company, shall do the following: repair, alter, open, or make connection to the services gas piping, or do any other work on parts of the gas supply system up to the meter set assembly or the service regulator where there is no meter. Again, the clear demarcation here or point is stated regarding the gas supplier's piping and who can work on these components and parts of the system. C, meter or service regulator when a meter is not provided. Again, no person, unless in the employ or authorized by the gas supply company, shall disconnect the inlet of the gas meter or service regulator where there is no meter, nor move such meter or regulator. A gas fitter may disconnect the outlet of such a meter or regulator from the house piping only when necessary. He shall make the joint at the meter or service regulator out there where there is no meter. carefully replacing all insulating fittings or insulating parts of such fittings, and shall leave the gas turned off at the meter or regulator unless the gas supply company's rules require or allow deviation from this procedure. What's indicated here in C, item C, is the clear description of who may work on these parts of the system and how it must be left when repairs are done and the installation is done. Item D, notify gas supply company of any repairs needed. In case any work needs to be done, the gas fitter reveals the need for repairs or alterations on any part of the gas supply system. The gas supply company shall be notified promptly of this fact. Again, we need to notify the gas supply company because, after all, they are responsible for the supply of gas to the consumer. And if there's any problems or repairs that need to be done on the gas supply company's side of the piping system, notification of any repairs to the gas company is required. Now, the very last one here, notify gas supply company of any leakage. This is item E. If gas is leaking from any part of the gas supply system, a gas fitter or plumber not in the employ of the gas supply company may make necessary repairs and shall promptly notify the gas supply company. There we have it, Appendix V. This is where we go to work on gas supply system. All the requirements are given here to the code user. Notification of completion. Section 8.1.4.1 gives us, when regulations so require, the completion of installation shall be notified to the gas supply company or the authority. So whenever we have a new gas system installed, we need to notify the authority for proper installation, maybe inspection, testing, and startup of the gas system. Section 8.2.2 is titled Size of Gas Piping to Appliances. This section is very important not only to the designer but to the installer as well. Properly understanding some of the design constraints, the analysis that has to be done before any gas piping system is even proposed, we need to understand certain factors that go into the design procedure. Section 8.2.2.1 gives us the following. Gas piping shall be of such size and so installed to ensure adequate supply of gas to meet the maximum demand without undue pressure drop between the meter or service regulator, where there is no meter, and the appliance or appliances. Section 8.2.2.2 tells us a little bit more about the factors that need to be considered here. It indicates the following. The size of gas piping depends upon the following factors. Factor number 1 is given to us in 8.2.2.3. Allowable pressure drop from meter or service regulator when there is no meter to appliance. 8.2.2.4, maximum gas consumption to be provided. 8.2.2.5, length of piping and number of fittings must be considered as well. Because as you know, lengths of piping. The longer the piping, the more restriction, the more pressure drop. The greater number of fittings equate to lengths of pipe, different pressure drops, valves, things of that nature contribute to the pressure loss of the system. 8.2.2.6 is specific gravity of the gas. This needs to be understood in order to apply the correct calculation or tabular values when you are designing gas piping. Finally, the last factor that's indicated here is 8.2.2.7, diversity factor. As seen in the chart here, we've broken this down into information that's a little easier to understand. Up on the top of the chart, you'll see 4 different columns. The first column is titled Needed Information. This is a good summary to help the designer and everybody interested in fuel gas piping to completely understand what certain factors go into the design of gas piping system. The second column gives us a general definition or a description of what we're talking about specifically for that row. Explanation is the third column, and it gives us some explanatory material to further understand the intent of this summary chart. And finally, where located is a recommendation to where the information should be required for review and approval and installation. Let's start out with pressure drop in the first row, or we could say pressure loss. The needed information indicates the following: allowable loss in pressure from point of delivery to gas appliance. This is very important here because we need to make sure that we provide the correct volume at a minimum to the appliance. How do we get that gas from one point to another? The volume is what we're talking about. We need some pressure in the system. Pressure will move the volume of gas. The point of delivery is normally the outlet of the first fitting downstream of the gas meter. Again, just general information here to help us understand further proper design factors. Definition: the loss in pressure due to friction or obstruction in pipes, valves, fittings, and regulators. The explanation: this is the designer's choice. The designer must come into a proposed system and come up with the best solution for the given situation. Finally, where located, indicated on plans. This is pretty important because we need to understand what the design basis is. Number one we're talking about is the pressure drop. Pressure drop is very important. We need to understand what the pressure drop or loss is so we can overcome those pressure drops simply by increasing the pressure, increasing the pipe sizes and fittings together, things of that nature. So many different options of the designer, but we need to understand pressure drop. Demand is the next row that we're going to be taking a look at. The information needed: maximum gas demand. The maximum gas demand considers the appliances that will be utilizing the gas. When we design gas piping systems, we have to understand completely what type of appliances are being installed to properly meet the demand of the system. Definition: the total volume of gas used per hour by all appliances as indicated on each appliance label. Now, we're given a demand, of course, maybe an input value of the appliances in kilowatts or kW. We're very interested in that value. Explanation. The piping must be sized to accommodate full length of gas runs and simultaneous utilization of the gas appliance in the plant. And we'll look at diversity factor below and qualify when and where we can modify the demand of the system. Finally, where located, we need to understand the designer's intent. We need to understand the limitations of the designer's intent, that is, because the demand is so important. We need to indicate this on the plans accordingly. So we've got two components. Pressure drop, we have demand. The information must be conveyed to the approving authority. And once that is on the construction documents, it's very good communication for everybody to see the factors involved in the design of the gas piping system. Next is pipe length and fittings. Length of pipe and number of fittings. The definition, this is the distance of each segment of pipe. When it comes to fittings, when using the tables for designing gas piping system, if applicable, any additional allowance is necessary where 4 or more fittings are used. There's different procedures that the designer may want to use instead of tabular values. Calculations are available as well. The explanation, scaled drawings of both plans and elevations are required to determine full length of gas runs from the most remote outlet to determine if the piping has been properly sized. Where is this information required? On the plans and construction documents. Pipe sizes. Labeled pipe sizes. We are concerned with the pipe sizes. This gives us the diameter of the piping segments throughout the whole system so that the installer may install the correct pipe size as long with the number of fittings conveyed by the designer. That is the definition. This is the diameter, of course, and also the type of pipe to convey the gas. Different types of piping materials are indicated in our gas code, and we will look at those different types of approved piping materials shortly. The explanation. Each pipe segment must have its size and type material called out on the plan to be able to be verified that it has the required capacity to satisfy the demand. This is required on the plans and construction documents. Specific gravity of the gas. The definition is the ratio of the weight of a given volume of the gas to that of the same volume of air, both measured under the same conditions. The specific gravity of gas, the information can be found from the gas provider, whether it's a utility, whether it's a LPG system, things of that nature. You can find this out from the gas supplier. This enables us to properly integrate this specific gravity into the design of the gas piping system. Last, we have diversity factor or correction. This is the volumetric flow rate of gas to be provided. It shall be adjusted for altitude, where the installation is above 2,000 feet. Typically, if we use tabular values, we are given a percentage, if you will, to differentiate for different altitudes, but that is the threshold value. The definition: designed for predicted gas demand that is less than the total aggregate demand, or other specific circumstances of a job that might alter application of code provisions. Now, maybe we have an appliance, two appliances per se, that may not run at the same time. The designer must consider this and design for the higher input value of the appliances at hand. Knowing that they will not be on at the same time, the designer will take the maximum demand of the two appliances and integrate that into the design of the gas piping system as an example. Explanation: when it is not probable that all appliances will be operated simultaneously, here it is, a reduction can be factored in accordingly. So again, we need to understand the type of appliances, the function of the appliances, and the operating characteristics and control of the appliances as well to make good informed decisions about designing the gas pipe system. As an example, we have a gas piping system shown in the graphic below. As you see where the gas system receives its supply from the utility or the authority, it comes into the meter set. Out of the meter set, it supplies the consumer's or customer side of the system. The gas piping is run to all outlets that need to supply appliances as installed. So keeping in mind that the gas piping system must be sized to accommodate full simultaneous utilization of all of the appliances in the plan. Unless, of course, there's some diversity factor that we discussed, as indicated in the previous chart. However, any exceptions to this principle must be substantiated with full documentation in a plan review of the gas piping system. The systems must contain adequate capacity for anticipated modifications, maybe additions, or additional appliances. The evaluation must be conducted on the complete system as it will be configured after the appliances are added. Section 8.2.2.8, the size of each gas piping system shall be determined by standard engineering methods acceptable to the gas supply company and the authority. We will first look at Section 8.2.2.9. Gas pipes smaller than 12 millimeter in diameter shall not be used. This is the first requirement that is limiting the materials that are permitted to be used. So in this case, we cannot use any piping smaller than 12 millimeter in diameter. We have a prohibited material here in the next section. And again, we're talking about acceptable piping materials. Section 8.2.3.1 gives us a reference as seen here. It indicates the following: piping material shall be one of the materials listed in Table 8.8.1, conforming to the corresponding standards, or other materials as may be approved by the gas supply company or authority. Finally, cast iron pipe shall not be used. Think of the characteristics, or the material characteristics, we should say, about cast iron pipe. Cast iron pipe is brittle compared to malleable metals. It's more likely to fail under stress. Brittle materials crack, ladies and gentlemen. We do not want any gas piping or any part thereof subjected to leaks, things of that nature. Materials must be durable for the suitable gas piping system to be designed, and this here prohibits specifically cast iron pipe. Understanding that this is the very first section that we run into that gives us regulations of the type of materials permitted to be used for gas piping. The reference is given to us by means of a table that we will locate. Section 8.2.3, Acceptable Piping Materials, contains Table 8.8.1. When we look at this table, on the left-hand side, the table indicates the piping materials that are suitable for gas piping systems. Some of the materials you'll see are black steel pipe, galvanized steel pipe, wrought steel, wrought iron pipe, corrugated stainless steel tubing, that's abbreviated CSST, can be utilized as well. That is a manufactured product, and it is a proprietary type of a product with manufacturer's installation instructions. As seen, other permitted materials are copper or copper alloy tubing, type K or type L, aluminum pipe and tubing, and finally plastic pipe and tubing. The asterisk indicates minimum Schedule 40 pipe, as indicated for black steel, galvanized, and wrought steel piping materials. On the right-hand side, there is the associated standards, ladies and gentlemen, that the piping is manufactured to, tested to. These are standards that are listed for use with respect to the associated materials. When you install the piping materials, it's easy for the inspector to locate the piping, understand the standards due to the manufacturer's stamping on the pipes accordingly. To the right of the table, we have an example. Black steel pipe, Schedule 40. As you can see, steel pipe must be Schedule 40 or heavier, and it must comply with one of the listed standards and can be black iron or galvanized accordingly. Another material that is in the table is corrugated stainless steel tubing. Now, as indicated before, we have a standard that this particular tubing needs to comply with. It's ANSI LC1 or CSA 6.26. This provides material and performance criteria regarding this specific material. Now, corrugated stainless steel tubing is just that. It's a stainless steel material. It has corrugations in the tubing, and it is manufactured specifically for gas piping systems. However, the installation requirements are proprietary to the manufacturer that manufactures this particular material. It's a manufactured gas piping system with several proprietary components like valves, fittings. We have what's called a two-piece ferrule type fitting. It's actually a compression fitting that, when made properly in accordance with the manufacturer's installation instructions, will make a good gas-tight seal. Another material that is permitted is copper or copper alloy tubing. The designer has two choices here, whether to use type K or type L copper. Type K copper is your thicker wall copper. Type L is your next wall thickness that is a little bit thinner than type K. In either condition, there are two standards listed in the table. So copper tubing, copper, needs to comply with standard ASTM B88 or ASTM B280. Now, just a note, verification must be obtained from the designer prior to using copper or copper alloy tubing, due to the fact that in some cases, if the gas contains more than an average of 0.7 milligrams of hydrogen sulfide per 100 liters of gas, you need to contact the local natural gas company to find out exactly what the concentration of hydrogen sulfide is. Hydrogen sulfide has a corrosive type of an effect on copper materials, so it's advantageous to understand that initially before selecting materials for the gas piping system. Another material that's indicated in the table is aluminum pipe. Aluminum alloy pipe shall comply with ASTM B241, except that the use of alloy 5456 is prohibited. Aluminum alloy pipe shall be marked at each end of the pipe length, indicating compliance. So we're looking for the marking of the standards on the pipe itself. Aluminum alloy pipe needs to be coated to protect against external corrosion. Of course, when it's in contact with masonry, plaster, or insulation, or is subject to repeated wettings, such by liquids such as water, detergents, or sewage. Aluminum alloy pipe shall not be used in exterior locations or underground. Understanding some of the material constraints here help us understand when and where to select piping materials based upon your given application. So as designers, we need to focus in on the application. Where is this piping going to be installed? And select proper durable materials for the environment as well. So aluminum pipe is not commonly used for gas service because aluminum is fairly reactive material. It corrodes readily when exposed to a variety of materials and the environment. However, it can be used in certain areas. And again, this is up to the designer to select the correct material. Plastic pipe is listed in the table, plastic pipe and tubing. The installation of plastic pipe and tubing is limited to areas that are both outside of the building, outdoors, and underground because of the potential hazard associated with the use of the material. It has a lower resistance to physical damage and heat compared to metallic pipe and tubing that are given to us in the table. Section 8.2.4 is the section that we go to for fabrication of piping for installation. Now, when we enter this section, we are given some information here. regarding gas piping, tubing, and fittings. 8.2.4.1 gives us this initial information and requirement for this piping to be installed accordingly. Gas pipe or tubing and fittings shall be clean and free from cutting burrs and defects in structure or threading, and shall be thoroughly brushed with chips and scale blown. In other words, we don't want any type of debris to be integrated from the process of installation into the system. We need to make sure that we have a good, clean piping system. Defects in pipe or tubing or fittings shall not be repaired when defective pipe, tubing, or fittings have been identified. The defective material shall be replaced. Again, we want to install a good, clean, adequate piping system that meets the design. Section 8.2.4.2, when we have pipe, tubing, fittings, and valves removed from any system, this is an existing system, shall not be used again until they've been thoroughly cleaned, inspected, and ascertained to be equivalent to new material. So ideally, gas piping installations should be constructed of new materials. However, we have this section that allows reuse of existing materials. If the materials are adequate, durable, and indicated and ascertained to be equivalent to the new material, then the authority may accept these materials as being acceptable for installation in the gas piping system. We need to make sure, though, that the materials meet the standards accordingly, and there's some very strict criteria that intend to reduce the potential for poor performance. That's what the standards are all about for materials. We need to make a complete system installed in a safe manner that conveys the adequate volume of gas under pressure as designed by the engineer. Here we have an example of a newer press-type fitting. The ICC International Fuel Gas Code now recognizes new pipe joining fittings like this for copper pipe, copper tubing. Press connect fittings that comply with ANSI LC4 are allowed for copper piping and tubing. They're similar, but they're not interchangeable with those used in the plumbing industry. As stated and can be seen here, we have an example of the fitting and a detail. As you see here, the yellow elastomeric O-rings that are integrated and manufactured into the fitting provide the seal from the fitting to the copper tubing. The proprietary compression tool that is used to compress the fitting to the pipe actually provides a force that crimps the fitting onto the pipe. When this force is applied, the end result is a gas-tight fitting. So again, the press tool compresses the portion of the fitting around the O-ring that's integrated and manufactured into the fitting. Fabrication is integrated here. We also have to take a look at section 8.2.4.5. Whenever we have piping and fittings used in different environments, this section gives us some requirements. when used in a corrosive environment, metallic pipes and fittings shall be protected with corrosion-resistant coatings. We need to prevent any type of corrosion that could be detrimental to the pipes, the fittings, and cause leakages, failure of fittings over time. Section 8.2.4.6 gives us the requirement for any thread joint, proper sealant shall be used on the made threads only. Therefore, we use it on the threads only. 8.2.4.7, joints and joining compounds, if used in LPG installations, shall be resistant to the action of liquid petroleum gas. Now, certain compounds may react with LPG. It's up to the designer to properly specify what type of joining methods, compounds may be used in that type of system. LP gas can react with some pipe sealants. This also may be the case for other gases as well. Therefore, the text simply requires that the sealant be compatible with whatever is conveyed in the piping. 8.2.5.1, installation, repair, and replacement of gas piping or appliances shall be performed only by a qualified installing agency or gas fitter. We need people that have qualifications to practice good piping standards, good piping installation standards for replacement of gas piping, replacement of appliances, or other components on the gas piping system. These people are trained for that particular application. 8.2.5.2, piping shall be buried to a minimum depth of 1 meter, covered in a manner so as to protect the piping from physical damage. It shall be protected from physical damage when it passes through flower beds, shrub beds, and other such cultivated areas. The depth here, ladies and gentlemen, is to provide some protection from things such as cultivating materials and tools utilized to dig up the surrounding earth, such that we do not hit the gas piping system and cause damage or even leakage to the system. So we have a minimum depth indicated here of 1 meter. As can see by the graphic here, the gas pipe is buried at least 1 meter below the finish grade accordingly. Additionally, keeping in mind, we need to protect this gas piping from damage. Protection against corrosion. Whenever we have gas piping, ladies and gentlemen, in contact with the earth or other materials that will corrode the piping, we need to protect it in an approved manner. There are plenty of materials out there to protect gas piping systems. However, the very last sentence of section 8.2.5.3 tells us the following: when dissimilar metals are joined underground, an insulating coupling or fitting shall be used. So we're concerned with different types of metals that could have a corrosive action or effect on the piping materials. Last, piping shall not be laid in contact with cinder or ash. This has a direct corrosive effect on materials in the environment, such that we look to metallic piping materials as being affected by cinders and ash. So the protective coatings come in the form of wrappings, tapes, enamels, epoxies, sleeves, casings, and factory-applied coverings. These are common methods of isolating metallic piping metals from the atmosphere or even from the earth in which they're buried. Corrosion can be caused by soil or construction materials that are in contact with the pipe. So this section gives you the charging requirements to protect the gas piping system from corrosion. Section 8.2.5.5. When piping is passed through foundation walls, this section helps us understand when and where and how to provide the installation of gas piping through the foundation wall. It states the following. This code section will give you the requirement as follows. Underground gas piping, when installed below grade through the outer foundation or basement wall of a building, shall be either encased in a protective sleeve or protected by an approved device or method. The piping or sleeve shall be sealed at the foundation or basement wall to prevent entry of gas or water. The graphic below shows a gas pipe penetrating through the foundation wall below finished grade. As such, complying with this section, we have a sleeve that has been installed in the foundation wall that provides suitable load transfer around that pipe to prevent damage, and it must be sealed accordingly. Section 8.2.5.9, piping entrance to buildings. When gas pipe enters a building through a wall or floor or masonry or concrete, it shall be sealed against the entrance of water, moisture, or gas. Like the previous section we talked about, this application shows that the piping emerges from the grade underground and enters the building above grade. According to this section, we apply the requirement and seal the piping against entrance of water, moisture, or gas. So this is an above grade application of gas piping penetrating into the building. Section 8.2.5.8 gives us the requirement for piping supports. Gas piping in buildings shall be supported with pipe hooks, metal pipe straps, bond or hangers of an approved type, and material suitable for the size of piping. And it must be adequate strength and quality and located at specific intervals so that the piping cannot be moved accidentally from the installed position. Gas piping shall not be supported by other piping. Indicated below is some additional information. The International Code Council's International Fuel Gas Code and NFPA 54 provides a table for maximum support intervals. As seen here, the table is split into two halves, if you will. The left-hand side of the table gives us requirements for steel pipe of various sizes and the spacing of supports. On the right side, it gives us information for the nominal size of tubing, smooth wall size tubing in the outside diameter, as well as spacing of supports. As you can see here, the indication of the table is based upon the pipe diameters and the spacing of supports. So if we look at what is indicated as half-inch pipe, we know that to be 15 millimeter, and you can do the associated conversion for the spacing of supports, as well as looking at steel pipe again. 3/4 or 1 inch actually converts to 20 millimeter and 25 millimeter pipe, and 1.25 inch, 32 millimeter, and you can do the associated spacing of supports. However, a special note here that if the designer is going to use one of these reference codes or even refer to the codes as indicated here as additional information, CSST piping system design and installation is proprietary. We need to look at the manufacturer's instructions, because the CSST corrugated stainless steel piping systems have specific fastening requirements according to the manufacturer. So that must be integrated into the design shown on the plans and construction documents so the system can be installed properly according to the manufacturer. We are permitted to install piping within solid floors. Section 8.2.5.10 gives us a requirement to install the piping in such a manner. Piping in solid floors, such as concrete, shall be laid in channels in the floor suitably covered to provide access to the piping with a minimum damage to the building. We see a graphic here of concrete being channeled below the finish elevation. This is where we place the pipe into the channel, and we could have a removable cover as indicated to provide suitability to access the gas pipe that is below the finished concrete slab for any type of maintenance, repair, or even replacement. We have a section view below indicating the metal cover and the gas piping below the finish elevation of the concrete slab. Changes in direction of gas pipe shall be made by the use of approved fittings. Approved fittings may be threaded fittings on Schedule 40 steel pipe. They may be fittings associated with copper tubing, or they may be bending of pipe, factory bends or field bends. Whenever we field bend piping, ladies and gentlemen, they must be bent by employing approved procedures and equipment. We have pipe benders, ladies and gentlemen, that actually work to our benefit. The correct pipe bender for the correct outside diameter of pipe ensures that when the gas fitter properly attaches the pipe bending apparatus to the pipe, once bent, will be free from any kind of internal radius buckling or kinking of the pipe that may alter the flow within the system. So this section is key here. The driving language here is field bends shall be made by employing approved procedures and equipment. As shown here, there is a typical radius that is referenced in our standards, especially for tubing, metallic tubing. And as indicated here, the radius shall not be less than 6 times the outside diameter of the tubing. What we don't want to do is we don't want to flatten out that internal radius as indicated here. We don't want any buckling or kinking of the pipe to reduce the interior diameter of the tubing. So pipe must be bent with appropriate bending tools and materials. Some materials are not tempered or even intended to be bent. Therefore, consideration must be given to choosing the proper materials. Bending tools, of course, are designed to make bends without damaging the pipe. Pipe intended to be bent has a minimum bending radius, which must be observed, of course, to avoid any damage to the pipe and, of course, any restrictions in flow. Gas piping, according to this section 8.2.5.13, indicates that we cannot run gas piping through any air duct, any chimney, or even a gas vent, or ventilating duct or elevator shafts. We need to be concerned where gas piping will be placed within the buildings. We don't want to create any type of dangerous condition where gas may be allowed to accumulate by leakage or damage to the piping. So an air duct supply, maybe an area that creates a shaft that provides a path for the gas to travel, are considered to be locations where the problem of a gas leak could be compounded by spreading the gas or any result fire through the building. We need to understand exactly where this piping is to be installed. Also, in some locations, the gas piping could be subject to deterioration because of temperature or corrosive conditions, such as in air ducts or chimneys. Additionally, piping located in an elevator shaft may be subject to an additional hazard, resulting in mechanical damage to the pipe. In this condition or environment, damage from an elevator impacting the fuel gas piping may not only cause a leak, but it would also allow the gas to escape and travel up the elevator shaft. And this puts an undue hazard on any occupants within the building and puts them in immediate danger. We need to avoid this. The elevator code also intends to prevent the non-essential piping within elevator shafts. So looking at this section gives us some safety requirements based upon where we are permitted to install gas piping inside buildings. 8.2.5.21. We need to grade gas piping, ladies and gentlemen. That is, we need to pitch the gas piping according to this section. All gas piping shall be graded not less than 1 in 750 to prevent accumulation of condensation or liquids in the line. All horizontal lines shall grade to risers, and from the risers to the meter or service regulator when there is no meter, or to the appliance. Now, this is where we deal with condensation or liquids in the line, such as we may have wet gas being supplied, in which case we have to provide drips according to the code, or maybe even according to manufacturer's installation instructions. We need to provide the pitch to these specific areas as indicated in this code section, such that we do not block the gas piping system from the desired flow and pressure as designed. Again, when you have wet gas systems, maintenance is of the utmost importance to provide drainage of these particular locations periodically. The gas piping needs to be painted red in order to differentiate it from other piping. So where piping is exposed to sun rays, it shall be painted silver gray. When we think about the colors of materials outside, we're concerned with the sun's radiant energy, of course, and we don't want any dark colors because dark colors absorb heat. We want more of a reflective type of paint, and as indicated in this section, silver or gray will intuitively reflect the sun's radiant energy. If it's inside the building, not exposed to the sun, then we need to make sure that we have red paint to differentiate the gas piping from any other piping. We do not want any undue confusion within the building of some worker thinking that the gas pipe is actually some other system and cut into the pipe and cause leaks. When using this code, we have a reference to Appendix W. The code section that gives us this reference is 8.2.5.23, and it states the following: documentation shall be maintained for all gas supply installations. When we look to Appendix W, it gives us specific documentation for piping installation. Item A indicates that application for gas connection in prescribed form, along with approved plan of the building where the gas is to be used. If a building is not approved by the authority, its plan is to be prepared by an approved contractor of the gas supply company. So right there is a requirement from the authority on who is permitted to prepare the plan for the gas supply system. B, an approved contractor of the gas supply company shall prepare the plan of the gas piping system for the building. The plan is to include plan and elevation of the proposed piping system. The plan so prepared shall be submitted to the gas supply company. Item C gives us the requirement for documentation. Installation of the piping system as approved by the gas supply company shall be carried out by an approved contractor of the gas supply company. This part holds out an approved contractor of the gas supply company. So we can at least guarantee that there is a properly trained contractor approved by the gas supply company. Item D, completion report of the installation of the gas piping system using the approved drawing as indicated in the parentheses, along with the pressure and leak tests by the approved contractor shall be submitted to the gas supply company. So not only is the installation of the piping system provided by qualified individuals, there also has to be the pressure and leak tests provided by the approved contractor, and they need to be submitted to the gas supply company. The pressure test is to be witnessed by the approved official of the gas supply company. This even further ensures the tightness and the verification of the tightness regarding the pressure test by having the approved official on site witnessing the pressure test from the gas supply company. Item E, completion report mentioned in item D above is to include the papers related to the permission from the authority for digging, cutting the road, for taking the connection from the main supply line lying under the road needed. Item F, the legal owner of the building shall sign an agreement with the gas supply company using the prescribed agreement document of the gas supply company prior to having the gas supplied to his or her premises. So as can be seen in items A through F, this is the documentation. These are specific requirements for piping installation. Section 8.2.6.1 gives us information regarding pressure regulators. Where the pressure of gas supplied to a domestic installation or even other low-pressure gas piping systems in buildings is in excess of 3.45 kPa, a gas pressure regulator of approved type and size shall be installed in the service pipe of each such system. This is needed, ladies and gentlemen, to prevent pressure in excess of 3.45 kPa from being introduced into such a building piping system. If the building pipe is of welded construction, the pressure regulator may be located upstream of the gas meter in each consumer's premises. In these cases, the gas pressure in the piping downstream of the gas pressure regulator shall not exceed 3.45 kPa. As an example, this is called a pressure profile diagram. The example of pressure regulation from the service regulator to the appliance regulator to the appliance burner is given in this example. As indicated, we see a service regulator in a meter set. Please look at the underground piping emerging from the earth. It actually will go into the inlet of the service regulator. What you don't see here is the service valve that will be located below the service regulator. So the piping coming in from the supplier will enter the inlet of the service regulator. From that point, if the pressure is 69 kPa, we have to ensure that at this point, prior to going into a building supplied by low pressure or even a domestic installation, prior to going into the building, we need to regulate or reduce the gas pressure to something on the order of 3.45 kPa at a maximum. Now, due to rounding, I've rounded it off and showed you that due to the pressure drop, we're going to reduce this pressure to 3.5 kPa, as indicated in our pressure profile here. As we go through the meter with the volume of gas under this pressure, 3.5 kPa, we emerge from the meter set into the gas piping system that goes through the manifold and up to the appliance regulator indicated in the appliance. From that point, looking at the bottom of the pressure profile, we have a loss in pressure. It went from 3.5 kPa to 3 kPa of pressure as it enters the inlet of the appliance regulator. That needs to be considered, of course, in the design of the gas piping system by the engineer, as well as referencing the appliance manufacturer's installation instructions. Appliance installation instructions indicate the maximum and acceptable pressure to be supplied at the appliance regulator for certain appliances. We further reduce the pressure from 3 kPa to 1.75 kPa as the manufacturer indicates to supply the burner manifold in the appliance. Now, as you can see, we have regulated or reduced the pressure accordingly based upon service regulator and appliance regulator and good piping design to get from that point where it comes in to the building to the appliance. The gas fitter or the people constructing the gas piping and starting the appliances will reference the manufacturer's installation instructions and set the appliance regulator to the according pressure that is mandated by the manufacturer for proper operation of the appliance. If installed in a building, the regulator shall comply with the following. So if we install it in a building, we need to comply with this particular code section. 8.2.6.3, if any of the diaphragms of the regulator ruptures, the gas shall be directed to an outlet vent pipe made of brass or plastic in order to vent the gas out of the building. The vent pipe shall be installed about 1 meter above the topmost story of the building in open air. Means shall be employed to prevent water from entering the pipe and also to prevent blocking it by insects or other foreign bodies. When we reference this specific requirement, we have some examples below. There's a section view of a regulator, and as you can see, this is a flexible diaphragm. Sometimes the diaphragm may be damaged. It could rupture perhaps. When we have the gas coming in on the inlet and going above the seat, as you can see, the regulator part of the diaphragm actually increases, decreases, provides a cavity for the volume of gas to flow up over the seat, but it will not allow the gas to flow beyond the diaphragm. That's a sealed diaphragm. And it has to go above the seat, over the seat, and out the gas outlet. If the diaphragm should rupture, as you can see, the gas will actually go through the diaphragm and into the vent chamber and be vented through the roof. Looking at the elevation view, we can see the red pipe indicates the vent all the way attached from the regulator to at least 1 meter above the topmost story, or in this case, the roof itself. Pressure regulators are extremely important devices. They're relied on to prevent overpressurization of appliances and equipment. This is where we fine-tune the pressures in our gas piping systems. So typical gas appliance controls are not designed to tolerate a pressure of more than 3.5 kPa. The standards that regulate the design and function of appliance gas controls require that the controls be tested for resistance to permanent damage resulting from exposure to excessive gas supply pressure. So that's something that we need to think about when we specify these regulators. We want to specify good regulators that meet standards. Testing. To further explain this, each function of the gas controls must be tested for exposure to 17 kPa pressure for a period of 1 minute, after which the control must function normally. Again, this is all a function of testing standards, good quality materials that we will specify in the gas piping system. As inspectors, we are to look at the approved construction documents and make sure that these good quality controls that have been designed by the engineer are installed in the gas piping system. Service shutoff valves. we have two requirements that indicate service shutoff valves be provided. And where are they to be located? In section 8.2.7.1, we need to provide service shutoff valves on all new services, including replacements, and they need to be installed in a readily accessible location. As we can see in the picture below, we have service shutoff valves. The gas emerges from the ground in the lower shutoff valve as indicated on the rightmost part of the picture, right bottom part indicated by the arrow. This is where the main gas supply comes up, and from that service shutoff valve, it emerges and piped into a T. The T supplies another regulator, as you can see, on the leftmost side. So we, in essence, could have two service shutoff valves. Now, section 8.2.7.2 tells us that the service shutoff valves need to be located upstream of the meter. If there is no regulator, or upstream of the regulator, if there is one. We have a regulator installed at the meter, the large meter that you can see on the left-hand side. We have to have a service valve located upstream of that regulator. Upstream means prior to supplying the regulator, and as you can see below that regulator, there is, in fact, a valve at that point. And that complies with this section of code. All gas services, however, operating at pressures greater than 3.45 kPa need to be equipped with a shutoff valve of an approved type, and it needs to be installed on the service pipe outside of the building. This is regulated by the code section 8.2.7.3. The picture shows us the service shutoff valve installed according to this particular code section. Every gas outlet needs to have an individual shutoff valve required by 8.2.7.5. The shutoff valve shall be accessible and adjacent to the appliance. We can see we've got a water heating device here. As such, we have the shutoff valve that is accessible and it is adjacent to the appliance as required by this code section. Another application is where we have a commercial cooking appliance. In this case, the shutoff valve is again accessible and adjacent to the appliance. According to 8.2.9.1, no person shall use or even permit the use of a new system or even an extension of an old system of gas piping in a building or structure before the same has been inspected and tested to ensure that the system is safe and a certificate has been issued by the authority. The reference here is see Appendix W. You remember the documentation that needed to be provided to the authority for the gas piping system. 8.2.9.2 gives us testing of piping for tightness. The system needs to be tested, ladies and gentlemen, so we can verify that the construction and installation of the piping system is gas tight and it will not leak. And it must be tested to be approved and prior to operation verified that it is tight. Where any part of the system is to be enclosed or concealed, the test should be preceded to the work of closing in. So what we're saying here is we need to test segments of the gas piping system that are going to be either enclosed or concealed prior to concealing it in the construction. So as inspectors, we may have to be called out and look at the testing to be done and looking at the proper materials and fittings that make up the part of the system that will be concealed prior to building construction around that. The test medium shall be air, nitrogen, carbon dioxide, or an inert gas. Oxygen, of course, shall never be used because oxygen mixing with oil can be or produce quite an explosive type of an effect. Pressure test is required after every installation, every alteration, every addition, or even repairs to the fuel gas piping system. We need to verify that the system is tight and leak-free. The location of a leak may be difficult to determine, especially if it is concealed in the building construction. If a leak is found, the leaking component must be repaired or replaced before the system is concealed or put into operation. Inspection of services, again, takes on another requirement here. Before the appliances are connected, the piping systems are required by this section 8.2.9.3 to be tested at a pressure of at least 159 millimeter mercury for a period of not less than 10 minutes. And 159 millimeters of mercury is the equivalent to 20 kPa of pressure. Again, this is for 10 minutes without showing any pressure drop. And the source of pressure shall be isolated before the pressure tests are performed. In other words, the gas outlets need to be capped off tightly. We need to provide some type of gauge and a Schrader valve to input the pressure into the system. This way, when the inspector goes out to inspect the pressure on the system, we can readily look at the mechanical gauge pressure and indicate the proper pressure being applied to test the system. Additionally, we have section 8.2.10 that provides requirements for checking of leakage, and 8.2.11 provides requirements for purging prior to operating appliances. We need to keep this in mind. Appliance fuel conversion needs to be considered when you are converting from one fuel to another fuel. We have a requirement in our gas code, section 8.5.1.2, and it states the following. It shall be determined whether the appliance has been designed for use with the gas to which it will be connected. No attempt shall be made to convert the appliance from the gas specified on the rating plate for use with a different gas without consulting the gas supply company or the appliance manufacturer for complete instructions. We'll go over further details in the next slides coming up. The appliance fuel conversion must consider the following items. Now, a mismatch between an appliance and a fuel will create an extremely hazardous condition that can be avoided by examining the appliance label. The appliance label indicates the source of fuel that needs to be supplied to that appliance for proper operation. Fuel conversions that are not performed correctly can adversely affect the performance of burners, the venting of combustion gases, and proper clearance to combustibles. as well as another consideration when we have fuel-fired appliances are designed to operate with a maximum and minimum heat energy input capacity. This capacity might need to be field adjusted in accordance with the appliance manufacturer's instructions to suit the elevation because of the change in air density at different elevations. When we convert appliances to different types of fuel, the manufacturer may have kits that are available. As shown in the photos below, we may have to provide or install a brand new regulator, maybe to convert from natural gas to LPG. In addition, we may have to replace the orifices or the nozzles in the burners. This is an example of a label for more than one fuel. This label indicated here on the right-hand side, we've got a red rectangle indicating factory equipped for natural gas. So this appliance on this label is factory equipped for natural gas. However, you can see that there is an opportunity here to provide a conversion. The dashed rectangles that I have indicated on this label give us two separate columns. The first column is for natural gas. And as you can see here, we have maximum permissible gas supply pressure allowed to be provided to this furnace accordingly. For natural gas, we can see it's 2.61 kPa. The minimum gas supply pressure is indicated at 1.24 kPa. Now, to the right of the natural gas information contains propane or LP information. The maximum permissible gas supply when applying propane or LP gas is 3.23 kPa. The minimum gas supply pressure is indicated here at 2.49 kPa. And as you can see, the hourly input rating on the left-hand side for this particular appliance is 23.44 kW. So the appliance label gives us good information on exactly what type of fuel can be provided for this particular application. The installer must note, the inspector must note that the factory equipped fuel in this case is natural gas. So what we would probably do if we wanted to do a conversion is locate the manufacturer's installation instructions and find out exactly how to properly convert from natural gas to propane, because it is giving us information on the label. Now, many gas appliances are listed and labeled for more than one fuel. Most commonly natural gas and liquefied petroleum. Such appliances can be converted from one fuel to another using a manufacturer's conversion kit and specifically following the instructions provided by the manufacturer. The gas appliances shall be firmly supported. We're given this requirement in 8.5.1.6. We need to make sure that the appliances do not exert any undue strain on the connected piping and connections. Now, the next section I want to bring up is related to what we just stated. In 8.5.1.8, all appliances shall be located with respect to the building construction and other equipment so as to permit ready access to the appliance. We need to get to the appliance for cleaning. We need to maybe get to the appliance for replacement of parts, adjustments, cleaning of the burners, and regular maintenance. The picture that you see below is an example of a commercial cooking appliance. You can see the wheels or the casters on the bottom of the appliance. This is utilized to move the appliance away from the wall for proper cleaning, as well as to access the regulator, the pipe fittings, the valves, things of that nature. However, what is indicated in the dashed rectangle is showing you that we have a tether made of a cable. The commercial cooking appliance is attached to a cable that fastens from the appliance to the wall, such that when workers are cleaning in back of the appliance, we do not put any undue strain on the appliance gas connector, as you can see here. All the strain will be put or placed upon the cable and transmitted to the building structure. This is a good safety requirement for any of these appliances on casters, is to put the associated cable installed as such and indicated herein. We have gas appliances that we need to verify do not cause a problem, in that we do not want any sources of ignition in certain environments. We have a requirement in 8.5.1.4 that gas appliances shall not be installed in any location where flammable vapors are likely to be present or accumulate, unless the design, operation, and installation are such as to eliminate the possibility of ignition of flammable vapors. As shown in the graphic below, we have a gas-fired appliance. We may need to elevate that appliance to be above any type of flammable vapors that may be hovering close to the finished floor. This is where we have flammable vapors that are heavier than air, ladies and gentlemen. In order to reduce the possibility of ignition of flammable vapors in hazardous areas, the potential sources of ignitions must be evaluated and be elevated above the surface, supporting the equipment or the appliance. We need to get it up higher so any source of ignition, such as a pilot burner, a spark igniter, a gas burner, does not ignite any vapors, as we mentioned. Some flammable and combustible liquids typically associated with hazardous locations, of course, give off vapors that are denser than air, and they tend to collect near the floor. So, designers, engineers, installers, inspectors, we all have to be aware of this, and we need to make sure that the appliances, number one, designed by the engineers, are specified at elevations and areas that do not permit readily ignition of flammable vapors that may be present in certain environments within our buildings. Connecting the appliances and the equipment. We're given 3 requirements here. 3 requirements in this slide are very specific, and there are more requirements. So the first requirement here is appliances and equipment shall be connected to the building piping system by one of the following. This sets up a series of choices by the designer. In 8.5.1.10, we have rigid metallic pipe and fittings that could be used to connect the appliance. As seen in the photo below, we have a rigid metallic pipe. This is Schedule 40 pipe, steel pipe, and fittings that are used to connect the appliance to the gas piping system. Another choice of the designer is 8.5.1.11, semi-rigid metallic tubing and metallic fittings. Aluminum alloy tubing shall not be used in exterior locations. Again, remember that aluminum has corrosive tendencies when located in certain areas. So again, this is prohibited specifically here as being used as an appliance connection material. To continue the list, we look to 8.5.1.12. This is a requirement that can be specified by the designer as well. Listed appliance connectors, and only one connector shall be used per appliance. As indicated in the graphic below, we have a shutoff valve coming in from the gas supply system, and we're using an appliance connector. Only one appliance connector per appliance. We also have the semi-rigid tubing in lengths up to 2 meters that are in the same room as the appliance. We can use listed gas hose connectors to be used as approved, and that is given to us in section 8.5.1.14. Point 15 indicates the connector or tubing shall be protected against physical and thermal damages. Point 16, aluminum alloy tubing and connectors shall be factory coated to protect against external corrosion where they're in contact with masonry, plaster, or insulation, or subject to frequent wettings by such liquids as water, except rainwater, of course. However, detergents or sewage also have a corrosive influence on aluminum alloy tubing. So, point 16 gives us some specific requirements based upon the aluminum alloy tubing when you connect appliances as such, and it must be followed in accordance with that code section. 8.5.1.17 is any appliance connected to a piping system shall have an accessible approved manual shutoff valve with a displaceable valve member or listed gas convenience outlet, and shall be located within 2 meters of the appliance it serves, except as permitted by the authority. As can be seen by the graphic here, we have an appliance and we have the accessible approved manual shutoff within 2 meters of the appliance, as indicated in this code section. Connecting the appliances and the equipment, we also have the ability in 8.5.1.18 to utilize what we call a listed quick connect device. And with respect to the graphic that's shown, or the picture here, you can see that this is a 2-piece system. On the left-hand side, we have the valve and mating quick connect device. In the code section, it's specific because it indicates the requirement that appliance connectors may be connected to building piping by a listed quick disconnect device. And when installed indoors, a manual shutoff valve shall be installed upstream of the quick disconnect device. Now, the picture down here shows a valve that is actually manufactured into this quick disconnect device. So you can buy these accordingly. And this is the end of the presentation. We hope that you enjoyed this presentation, and there is a quiz for you to take in the next several slides.